So here is some points you need to consider when you design your mesh. Take this example, which is actually taken from Stu's book. Say, if you want to forecast for a hurricane, what horizontal resolution should you use? And one rule of thumb is the actual resolution. That means the smallest weather feature that can be modeled is about 7 times the grid spacing. So take this example. Assume that such hurricane composed of many thunderstorms actually are dense here. And what you need to resolve is phenomena happening in the thunderstorm. Then how should you specify the horizontal grid spacing such that you are doing a meaningful simulation of the hurricane? Then you use this formula. You want to resolve the thunderstorm in the eye wall of the hurricane. So what you want to resolve is 17 km length scale. Then you need to divide it by 7, and you arrive at the grid spacing of the mesh you use have to be 2 kilometers or finer. How about the surrounding? And how about the size of the so-called domain that need to have 2 km resolution? So you need to consider the size of the feature you want to simulate. For hurricane, maybe the length scale is 300 kilometers. So when you design the size of the domain that you will specify 2 km target resolution, you need to consider the size of it. And usually you give some buffer region. So one answer would be to specify a domain to have 500 kilometers wide. And in this domain, the target resolution is 2 km. Then you will arrive at the number of horizontal cells you need to have. That may be a huge number, and that will consume quite some computational results. So how about even outside of these 500 domains to cover the globe? Outside, how coarse resolution can you use if you want to save computational resource? So the question is, what phenomena you need to simulate for your prediction target? For example, if the target of your prediction is the track of the tropical cyclone, then you will ask, what will affect the track of the tropical cyclone? For Asia, for Hong Kong, would it be the subtropical high in the North Pacific Ocean? Would it be monsoon happening at that period of time? Would that be, this is a challenging part, would that be another tropical cyclone nearby? So you have to design the outer region and specify the target resolution of that big outer region so that the simulation of the phenomena that affect the target of your simulation is appropriately simulated. Next is if you don't already know these tools, you have the estimation detail button. And I can demo it to you. So if you use a handling mesh draw last time, firstly, I need to turn off this estimation detail will not be available for limited area mesh. So I turn it off first. Let me see whether I can turn it off. No, it seems that once you turn it on, you cannot go back. Then I would make a new one. Okay, if I turn on estimation detail, it will already say the number of horizontal cell is 30,000 something if the cost resolution is this one. And then if I add a refinement region, maybe Taiwan this time. And then you will see that the estimated number of cells will increase. Of course, you know your limit, 200,000. And how big should I specify this region to be? If you don't already know, you can use this edit button and then go back, and then I want a larger one, and then save. And then this will change. And if you turn this on, you will roughly see something like transition going outside. Like in this region, for the target resolution is 4 km, and then you use mouse over to go out. This will be a transition going out to 8 km, and then the number of cells spent here has an estimated number, and then you move your mouse outside. It will have a transition to 16 km resolution with the transition zone around this boundary, and then the number of cells. Okay, go on and so forth. This tool may help you estimate the resource in terms of number of horizontal cells along your design of your mesh. Okay, and then maximum resolution gradient is one field I shall show. The default 1/12 is actually quite steep or too steep. If you want more smooth transition, then you will specify number like 1/36 or something like that, but it will consume more computational resource. Say this one you can change to, okay, you recognize this now. Highest number is 65,000. If you change this to 36, okay, enter, you will see that the transition will be smoother. But at the same time, it will consume much more computational resources. So it is up to you to do this design.